Good evening. I welcome you all for today's session, asynchronous sequential circuits. This asynchronous sequential circuits are nothing but finite state machines. First, we should know about asynchronous and synchronous. Before moving to that, the last type of flip-flop is master flip-flop, master slave flip-flop. We are going to discuss about the master slave flip-flop in this session. So, from the word itself, we understood what is master slave. Whatever the master do, the same will be followed by the slave. This is master slave flip flop. Okay. So the master slave JK flip flop is basically a combination of two JK flip flops connected together in a series configuration. It is not must that we have to use only JK flip flop in master slave. Whatever flip flop in it we can use either SR flip flop or T flip flop or D flip flop. Out of this, one acts as the master. So here we are using JK flip flop, two JK flip flops connected together. Out of these two, one acts as the master and the other acts as a slave. The output from the master flip flop is connected to the inputs of the slave flip flop, whose output is fed back to inputs of the master flip flop. In addition to these two flip flops, the circuit also includes an inverter. The inverter is connected to clock pulse in such a way that the inverted clock pulse is given to the slave flip flop. In other words, if CP, that is our clock pulse, is 0 for a master flip flop, then clock pulse is 1 for a slave flip flop. And if clock pulse is 1 for master flip flop, then it becomes 0 for the slave flip flop. So this is the circuit of master slave flip flop. You can see two JK flip flops connected here. First JK flip flop 1 and JK flip flop 2. So in this JK flip flop, we are giving two inputs like set and reset. First one is master. First JK flip flop will act as a master and second JK flip flop will act as a slave. Okay. So in this flip flops, we are giving a common clock pulse and also we are using a buffer here from second clock pulse and the buffer connected to both first and second with a clock pulse included a buffer. So the working principle of a master slave flip flop is when the clock pulse goes to 1. So we had seen the flip flops here. When the clock pulse goes to 1, the slave is isolated. J and K inputs may affect the state of the system. The slave flip-flop is isolated until the CP, that is our clock pulse, goes to 0. When the clock pulse goes back to 0, the information is passed from the master flip-flop to the slave and the output is obtained. The master flip-flop is positive level triggered and the slave flip-flop is negative level triggered. So, the master responds before the slave. If J is equal to 0 and K is equal to 1, the high Q bar output of the master goes to the K input of the slave and the clock forces the slave to reset. Thus, the slave copies the master. If J is equal to 1 and K is equal to 0, the high output of the master goes to the J input of the slave and the negative transition of the clock sets the slave copying the master. If J is equal to 1 and K is equal to 1, it toggles on the positive transition of the clock and thus the slave toggles on the negative transition of the clock. If J and K is equal to 0, the flip-flop is disabled and Q remains unchanged. This is the working principle of a master-slave flip-flop. And the master-slave JK flip-flop is a memory element widely used in digital systems. If you want to dive deeper into digital logic and the master the flip-flop mechanisms, the authors detailed explanations and examples to help you understand this important concept. So this is the timing pulse output waveform of our master slave flip-flop. So whatever the master receives, the same, see, you can see the master flip-flop QM represents your master output and QS represent your slave output. So this is all about our master slave flip-flop. Thank you.